Have you ever really stopped to think about what happens when you hit run on a program? I mean, how does the code that we, as developers, write get turned into something a computer can actually work with? Well, today, we're going to follow that exact path. We're going to uncover the secret language that bridges the gap between us and the machine, right in the heart of the .NET framework.
So just look at this. On one side, you've got what a developer writes, something clean, readable, in a high-level language like C#. It's made for humans. And on the other side, well, that's what the computer's processor actually gets. Just a long stream of ones and zeros. It's called native machine code. And you can see the gap between these two is, well, it's huge.
So that's the big question, isn't it? How in the world do we bridge that gap? How does our nice, logical code get translated into the raw, fundamental instructions the machine needs to actually do stuff? That's the exact journey we're on today.
And make no mistake, this translation is absolutely essential. A language like C# is awesome for us, but to the computer's hardware, it's just gibberish. You gotta remember, every machine speaks its own unique native code, so our source code has to be converted into that specific language for it to run. There's no way around it.
Now, here's where it gets really clever. You might think .NET just does a direct one-for-one translation, but nope. Instead, it uses this really smart two-step process. First, our source code gets turned into something called an intermediate language. Then, and only after that step, does that intermediate language get turned into the native code the machine understands.
So let's dig into that first step, because this is where the magic really starts. It's all about creating a kind of universal translator, and that translator is called intermediate language, or just IL. So what exactly is IL? Think of it as a middle ground. It's a totally language-neutral code. It doesn't care if you wrote C# or Visual Basic or any other .NET language. It takes all of them and turns them into one common format. But, and this is the key thing to remember, this is still not machine code. The computer's processor has no idea what to do with this. Not yet, anyway.
You're probably thinking, why bother with this extra step? Well, it's actually a genius move, because it creates this unified execution environment. By converting everything to IL first, .NET makes sure that code from any .NET language gets handled in the exact same way, a way that's secure and built for performance. It's way smarter than building a totally separate system for every single language.
All right, so we've been talking a lot about this mysterious intermediate language. But what does it actually look like? Come on, let's pull back the curtain and see what this secret code hiding inside our applications is all about.
Okay, but before I show you, a little warning. I'm going to borrow a line straight from our source material. The author asks, "It looks scary, right?" And, well, they're not wrong. But it is pretty fascinating.
And there it is. This is IL. Yeah, at first glance, it definitely looks a bit like old-school assembly code, right? You've got these little instructions like LDC, which means load constant, or mul for multiply. This is what the C# compiler actually spits out. We're not meant to write this by hand, but this universal code is exactly what gets packed inside your apps.exe file, just waiting for the final step.
So our code is now in this universal IL format, but it's still not ready. To take it the rest of the way, we need a hero. And in the world of .NET, that hero is the CLR, the Common Language Runtime. The CLR is, simply put, the engine for every single .NET program out there. Its number one job is to take that intermediate language we just saw, and right at the moment you run your program, convert it into the final native machine code that your processor can finally understand and execute. This is it. This is the final step.
But the CLR is so much more than just a translator. It's a full-blown runtime environment with some serious superpowers. It's automatically managing your memory with garbage collection, handling errors and exceptions gracefully, juggling all the application threads. It's the real powerhouse that keeps the whole system running securely and smoothly.
Okay, let's step back for a second. We've seen this two-step dance, from our code to IL, and then from IL to native code. But why all the complexity? Why does this journey even matter? What's the big payoff?
And here's the beautiful answer. One code, any machine. That's the payoff. Because the code is first compiled into that standardized intermediate language, it's not tied to any specific hardware. This means you can take that same compiled code, that same .exe file, and run it on any machine that has a compatible CLR. The CLR on that specific machine handles the final custom translation right there on the spot.
So when you add it all up, the advantages of doing things the .NET way become crystal clear.
You get this awesome, unified system where tons of different languages can all play together nicely. They all run inside this super secure environment that the CLR manages. And because that final translation happens just in time, the code is highly optimized for the exact machine it's running on, which means you get really high performance.
So we've seen that the CLR is basically the engine, the translator, and the security DAR for every .NET app. It is truly the unsung hero of this entire framework. And that leaves us with one final thought. Beyond translation and security, what other crucial jobs is this incredibly powerful runtime doing for us behind the scenes every single time we click Run?